All right, we're going to roll through scientific notation now. You should have done scientific notation at some point in your life. I would assume that you did. So you should have an idea of what, when I say scientific notation, what I'm talking about. You probably did it in science. Some of you may have done it in physics if you're in physics. But we are going to be we're going to be reviewing scientific notation, practicing writing numbers in scientific notation, and then we're going to do some operations in scientific notation. That is part of our curriculum, so we are going to do that now. There's some notes here, and then a few examples for reference, so you can kind of tell 4.15 times 10 to the fifth is 415,000. All right, because the decimal moves 5 to the right. So when you have a positive exponent on the 10, you move the decimal 5 to the right. When you have a negative exponent on the 10, you move the decimal, that number, to the left. So in this case, 3 to the left, 1, 2, 3 becomes 0.0016. The negative just carries along. And so this can be written as, and then going backwards, if you're given the large number, 1,740, it's going to have a positive exponent. And when you were given a really small number, like 0.00000, you know that's going to be a negative exponent. Okay, so that's kind of where that's going here. What I want you to think about and how this relates to what we're doing, why are we doing this? Well, it's exponents, negative exponents. 10 to the third is 10 to the third is 1,000, right? So basically what this means is you're doing 1.74 times 1,000. Okay, when you multiply by 1,000, that you know that moves a decimal 3 to the right. So that would be 1,740. Okay, 1, 2, 3. Add the 0 in. Now, negative 4, 10 to the negative 4. Let's think about that using exponents, which we have been doing. A negative exponent, remember what you do is you flip it. It goes 1 over. So 10 to the negative 4 is really 1 over 10 to the fourth. 10 to the fourth is 10,000. So it's 1 over 10,000. So what they mean here is to take 6.3, the number 6.3, and instead of, you're not multiplying by 10,000, you're multiplying by 1 over 10,000. So it's like 6.3 times 1 over 10,000, which is 6.3 divided by 10,000, essentially. When multiplying by 1 over is the same as dividing. So 6.3 divided by 10,000 gives you 0.00063. So if you could think about it in that way, it's another way of remembering it. Instead of just remembering I move left, I move right, because then it gets confusing. If I'm given the number, what it'll look like. So you may want to keep that in mind. All right, so let's roll through these examples here. Each number in scientific notation, so that's going to be 3.4 times 10 to the what? Okay, so 1, 2, 3, 4, 10 to the fourth. This is going to be 3.5 times 10. You might want to try these. Pause the video and then come back. 1, 2, 3. You have to move it 3 spots, but see how it's a really small number, 0.000? That's a negative, so it's going to be negative 3. All right, 5.321 times 10 to the what? 1, 2, 3, 4, 5, 6, 7, 8, 10 to the eighth. And 1.2 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. But it's going to be negative 9, because from here going here, you're moving it 9 to the left. See, 1, 2, 3. So if it was, say, pretend it was here, and you'd go 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. Okay, so 1.2 times 10 to the negative 9. Really big number, 34 quadrillion, whatever that is, 3.4 times 10 to the, they helped us out here by, instead of counting the zeros, they told us 24 zeros after the 4. So there's 24 zeros here, but that only takes us to right here, then you got to go one more, because you got to get in between the 3 and the 4. You don't want to get in between the 4 and the 0, you want to get in between the 3 and the 4 with the decimal. So that's going to be 24 and then another one, so 25. 3.4 times 10 to the 25. And then this is going to be 4.0 times 10 to the negative 22. All right? And that's because there's 21 zeros. You got to move it over to there, and then you got to go another one because you have to go after the 4. So I think you get the hang of this. Write the following numbers in decimal form. Okay, so now it's just an application. The Earth's age, the age of the Earth is 4.54 times 10 to the 9th years old. So how would you write that? Well, you would go 4.54, and then you would move that decimal 9 to the right. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and add in the number of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6. We had to add in 7 zeros, and boom, boom, boom. So it's going to be 4,540,000,000. 4,540,000,000 years old. A foot is 1.9 times 10 to the negative 4 miles. All right, so that means I take my 1.9 and I go 4 to the left. 1, 2, 3, 4. 1, 2, 3. 0.00019. 0.00019. We're rolling. Nice, easy one. Now, this is our last example here, and this is going to be operations. This is what you may not be familiar with. So now, to do the operations, you have to now think about what you know about multiplication and what you know about addition and subtraction. Multiplication and division have the same rules, just like everything else we do with multiplication and division. Addition and subtraction have the same rules. Multiplication and division, there are less rules. You can get away with more. Addition and subtraction, you have to be more careful. Think about multiplying and dividing, radicals or fractions or anything. You just multiply. You just divide. Okay? Adding and subtracting, you have to have like terms. You have to have the same denominator. You have to have common radicals. It's more strict. When you're adding and subtracting, there are more rules. It is more strict. You have to have common things. So when you get down to adding and subtracting, we'll talk more about that. The multiplying and dividing is a little easier. You literally can just multiply. So 1.5 times 2.4, and that's going to be 3.6. I already did this ahead of time to save us time in the video. So 1.5 times 2.4, multiply those, and that's 3.6. And then 10.5 times, not 10.5, 10 to the 5th times 10 to the 13th. Remember our rule for multiplying. What do we do with the exponents? We should know by now that we add the exponents. So this is going to be times 10 to the 18th. 3.6 times 10 to the 18th. We are in scientific notation, so we are done. That's it. Dividing. 6.42 divided by 2. Divide those guys. And you get 3.21. And then divide these guys. Now, when you're dividing, you subtract the exponents. 10 to the... Now, it's negative 5 minus 13. Negative 5 minus 13. That's going to be negative 18. And we are in scientific notation, so we are done. Easy stuff today, right? Why couldn't it be this easy all year, right, Mr. Ventry? Okay, 6 times 2.5, that's going to give us 15 times 10 to the, now 11 plus negative 5 is 6. Now this you have one more step because you can't leave 15 in scientific notation. It needs to be written 1.5. So we'll have to think now. 1.5 times 10 to the what? What would it be? I want you to take just 5-10 seconds and think about what you think it would be. And I'm going to explain to you how I'm going to get it. I know right now my decimal is here, and I'm moving it here, right? I'm moving it 1 to the left. To compensate for that, you have to move this. You have to move that 1 to the right. So if this is going to the left, this has to go to the right. That's got to be 7. So it's going to be 1.5 times 10 to the 7th. To check to see if you're right, just do this. Do this number. Move this from the decimal, move it 7 over to the right. Do this one, moving it 6 to the right, and you'll see that you get the same number. You will see that this is equivalent to this. Okay? Divide. 1.5 divided by 8 is 1875. And that, so divide those, and then divide those. 8 minus 10, negative 2. Now, that's not scientific notation. I got to write it as 1.875 times 10 to the what? Well, I got to move my decimal 1 to the right. So then I got to move this guy 1 to the left. Negative 2, 1 to the left becomes negative 3. All right, so it is 1.875 times 10 to the negative 3. Now, for more adding and subtracting, got to be more careful here. You have to have the same 10, the same exponent on the 10 in order to add. Just like you have to have like terms. So you could think of this as, don't write this. You could think of this like 7.6x to the 12th plus 5.2x to the 12th. If it was x to the 12th, you're good to go. You could just add the 7.6 and the 5.2. But here, it's like 5.8x to the 15th plus 1.4x to the 14th. If you had that, you would not be able to add because they're not like terms. So this is kind of the thought process you have to have here. So these are going to be easy. We already have 10 to the 12th, 10 to the 12th. 7.6 plus 5.2 is going to be 12.8. 12.8 times 10 to the 12th. Keep it the same. You keep it. Just like x squared plus x squared is 2x squared. X to the 5th plus x to the 5th is 2x to the 5th. You keep the exponent when you're adding. You keep the exponent. All right, now I can't leave that. I got to go 1.28, just like we did the other ones, times 10 to the what? Well, I moved it 1 to the left, so this has to go 1 to the right, so that becomes a 13. 1.28 times 10 to the 13th. This here, I have 8, so I'm good to go. 5.29 minus 1.12 is 4.17. 4.17 times 10 to the 8th. And that is already in scientific notation. We are good to go. How about these? Now, pay close attention here. Probably the hardest ones you're going to have to do. I have 10 to the 15th. I have 10 to the 14th. That's not going to work. What you want to do is take it to your higher exponent. So let's leave this one alone. 5.8 times 10 to the 15th. Leave that one alone. And let's write this one as times 10 to the 15th. So make the tens the same. 10, the powers of 10, make them the same. 10 to the 15th, 10 to the 15th. Well, how do I compensate? If I make 10 to the 14th, 10 to the 15th, I got to move that decimal. I'm moving it 1 to the right. So therefore, you have to go 1 to the left here. I'm making it 1 bigger, so this has to go 1 smaller. 0.14. You have to compensate to make the number the same. This 14 moved 1 to the right. It got bigger. It went to 15. So your decimal goes 1 to the left. And it's 0.14. Okay? So now I can add 5.8 and 0.14 is 5.94 times 10 to the 15th. And that is in scientific notation. And one more. I have, I'm going to leave this one alone, 8.2 times 10 to the 9th, minus, now I want to go 10 to the 9th, so I'm making that bigger, so I need to make that smaller. I got to make it 0.345. 0.345 times 10 to the 9th is the same as 3.45 times 10 to the 8th. All right, now I can subtract 8.2 minus 0.345 is 7.855, and then times 10 to the 9th. And here's a hint. By going to the higher exponent, see how I took the 8 to the 9 and I took the 14 to the 15? By going to the higher exponent, you won't have to, your answer is going to be in scientific notation most times. If you go to the lower exponent, you could do that, but then your answer, you're going to have to make it, put it in scientific notation because you're going to have more than one number before the decimal. All right, so we'll practice these more in class tomorrow. See you then.